So this is Preacalculus, Graphing Rational Functions, number 43. I guess the first thing I'm going to do here is I'm going to factor this out. And I had to look at this first, and it's not always true, but I'm wondering if they share any factors. And I think that they do, because I think that this thing factors out to this. I think that x plus 2 times x plus 2 is x squared plus 4x plus 4. And I'm hoping that x plus 2 times x plus 1 is this piece. We in agreement? Good. Okay. So here, there's an issue here, isn't there? And the issue that we're having, frankly, is that there's a hole in this function, a removable discontinuity. So we're just going to make this notation, hole at x equals what? At x equals negative 2. Because if we put in negative 2 here, this will go to 0 up here, won't it? This will go to 0, and 0 times whatever this is will go to 0. We'll have 0 over 0. No, that's a really good question. The question was, if x goes to negative 1, isn't that a hole? No, it's a vertical asymptote, isn't it? So just remember, you have to make a note of this hole at this value right here first, because then what are we going to do? It's called a removable discontinuity, so we're going to remove the discontinuity. So I'm going to go ahead and remove that, right? And then I'm going to evaluate this thing. Now I want to take f of negative 2, and f of negative 2 happens to be what? F of negative 2 is 0, so at the point negative 2, 0, there's a hole, and we have to go back at the very end and graph that hole in there, okay? So from there, now if you don't mind, remember that this is our new function, isn't it? This is f of x. So we're not working with this side anymore, we're working with this side now. So the first thing we said we're going to do is find the x intercepts. And the x intercept is when g of x, that the numerator is equal to 0. So we're going to take the numerator, which is x plus 2, and x plus 2 equals 0 at x equals negative 2. So that gives us the point what? Negative 2, 0. And that makes sense. It just happens. What's coincidental about this? Yeah, it's where the hole is also, right? So that's kind of weird, but I guess expectable. So moving on to the next part, we said that we are going to find the vertical asymptote, and the vertical asymptote is when the denominator equals 0. So we're looking for vertical asymptotes here. So when does x plus 1 equal 0? When x is negative 1. And if x is negative 1, we realize that the function becomes undefined here, doesn't it? So this function can't take this x value, right? And that's what's going to cause this vertical asymptote. The third thing that we said that we were going to do is we're going to find the y-intercept. Isn't that right? And the y-intercept is best described by saying what? F of 0, right? Because we know that everywhere on the y-axis, the x value is 0. So we take this function up here, and we say 0 plus 2 is 2. 0 plus 1 is 1. And that gives us the point 0, 0, 2. Again, I have to make this notation here because I want to make sure that gets on the graph. And lastly, last thing we're going to do before we start graphing is find not the vertical asymptote, but the horizontal asymptote. And what is the horizontal asymptote here? It's 1, isn't it? Because remember, we're comparing the exponential value of this to this. And we're saying that this exponential value is called n, yes? And this one is called k, and they're the same value, aren't they? So we take the ratio of their coefficients, and this is a ratio, has a coefficient of 1, and so does this. So we know this thing is going to go to y equals 1. Y equals 1 is the horizontal asymptote. Finally, we're able to graph, and we're just going to do this. We're going to set up our Cartesian plane. We have a vertical asymptote where? At negative what? Vertical asymptote is at negative 1? So our vertical asymptote is that x is equal to negative 1. Now what? Horizontal asymptote? Y is equal to 1. I wish that was a dotted line, but it's not. What else do we have? The X intercept is where? Something interesting about that? It's also the hole. So how do you graph that? You just actually make a hole, and you label that hole. And that is the point. Oh, it's at negative 2, 0, isn't it? Sorry. Negative 2, 0, and this has to be a hole, so let's make it.
Wouldn't it be on the outside?
Say that again?
Wouldn't it be on the outside of the asymptote because X equals -1?
Oh, good job. Wow, good job. Yeah, good job. It has to be here, doesn't it? Good job. Negative 2, 0. Really helps us now if you think about it. And the reason that it helps us so much is because I can see what this function has to do now, can't you? What is this function going to do? Is there another point we need? 0, 2. And that's here? That's great, isn't it? It's exactly what it does. 0, 2. So we know this thing does what? Comes down from here, doesn't it? Passing through this, heading out towards its horizontal asymptote here. And then what is it going to do here? Towards its horizontal asymptote here. Crashing against the vertical asymptote there. Yes or no?
Yes.
Nice work.